Welcome to DWBIADDA channel. Please subscribe for latest training videos.
Hello everyone, welcome back to the playlist on computer vision. In the last hands-on coding exercise, we saw about the reshape operator as well as we also had a look at some of the arithmetic operations that can be performed using Numpy array. In the last section on the Numpy hands-on coding exercise, we will have a look at the linear algebra operations using Numpy and some of the scientific operations that can be performed using Numpy. So without wasting much of your time, let's get started. I will quickly fire up my Jupyter notebook and write the code. I hope the code will be self-explanatory. So opening my Jupyter notebook over here, this is the last lecture notes where I taught you about the arithmetic operations and the reshape operations as well. Now we'll be talking about some of the some more operations, like some linear algebra operations on Numpy. So a linear algebra operations generally involves operation with matrices because matrices forms one of the core base for machine learning slash deep learning and data science. So it's very important to know, like, to find out the determinant of the matrix, trace of the matrix, inverse of the matrix, and stuff like that. So we will be using Numpy to find these three parameters as well, which will form the base for our linear algebra operations on Numpy. So I do already have a 4x4 matrix created over here in the form of D. You can see like this is the D matrix. And suppose what I want to do is, let's say I want to calculate the determinant of the matrix. So to calculate the determinant of the matrix, it's very easy. I will just write print np dot linalg, which is a short form for linear algebra, followed by dot det, which is the short form for determinant, and I will pass in D over here. And as soon as I run it, we'll see that I have got the determinant to be minus 166.006. So this is how we calculate determinant of the matrix using linear algebra operations. Similarly, if I want to find the inverse of the matrix, I just have to do np.linalg dot inverse, and I do have to pass the matrix D over here, and you will see inverse of the matrix appear over here. Now I can also calculate like vectors and eigenvalues of the given matrix. Like linear algebra provides you with functions to do that, like np.linearalgebra.eigenvalues and .eigenvectors, but I leave it upon you to actually explore more about it. Let's say I want to calculate the trace of the matrix. So to calculate the trace of the matrix, what I will do is I will just use np dot trace, because trace is directly a function in NumPy, and I will find D. So trace of the matrix is actually the sum of all the diagonal elements that are present in the matrix. So you can see like trace is 23. Let's verify whether trace is giving us the right answer or not. So this is supposed to be the D matrix. So 1, 4, 1 and 17, this is 21, 22 and 23, and 23 is the answer which we have got in trace. So this is how we actually work with linear algebra operations in NumPy. Let's move on to some scientific calculations using NumPy. Let's say, like, before moving with the scientific calculations, I want to introduce you to one more function which is known as a range function in NumPy, which actually is a way to generate numbers in a given range by using a particular step. So let's say I use the a range function. A range function has three arguments. The first argument is actually zero. The first argument is actually from where you want to start. In this case, I want to start from 0. The second argument is from where you want to end. I want to end into 3 pi. So I will just choose np.pi, and I want to take a step of 0.1. That means I will start from 0, I will end at 3 pi, and I will actually increment it by values of 0.1. So this is how we use a range function, which generates numbers in a given range for you. So I have stored this in x because I want to calculate the sine function, which is a scientific function using NumPy. And for y, I will actually write y is equals to sine x. And now what I want to do is I want to plot uh, this will be actually np.sin x. So now I actually want to plot the curve of sin x. So to plot the curve of sin x, I actually need matplotlib function. So you could plot easily using plt.plot in matplotlib. I'm not going into much details over here. I will directly show you like how to use it. So first I will import matplotlib.pyplot as plt. And after that, what I will do is plt.plot x comma y. As soon as I hit on this button, you will see that a sine curve has appeared on the screen. So this sine curve starts from 0 and goes till 3 pi. And like you know how sine curve is a decreasing, increasing curve, starts from 0, increases and decreases. This is how we use scientific functions in Numpy operations. Let's say you want to change it to, let's say, cos function. So I can do that as well. So I will just directly write np.cos, and I will rerun these lines again, and as you can see, it started from 1 and decreasing trend, then increasing trend, and it gave me a value for, or a graph for, cost function as well. So this is how you actually use the linear algebra and scientific functions in NumPy. I know it's not a lot, but you can explore it more on your own, because like there are a lot of different functions. However, we have discussed some of the very basic functions that are generally used while working with NumPy. I sincerely hope you like this tutorial and have learned something important from it. Hoping to see you in the next one. Till then, thank you.